So students, let's now understand what is beta function. So the improper integral, that is integration 0 to 1, just see here carefully, integration 0 to 1 x to the power m minus 1 multiplied with 1 minus x to the power whole to the power n minus 1 dx is a function of m and n. So in gamma function we understood that mm, that was the gamma function was only a function of n, but in beta function you have two variables on which the whole integral is dependent, that is m and is denoted by beta in within bracket m and n is known as beta function. So if I write the general form of beta function, it is beta mn equals to this, where the most important thing is where m and n both are greater than 0, where both are basically positive, right? Okay, so there is also another form of beta function in terms of sine and cosine, so let's check that. Okay, I'm writing, you can write with me also. Beta function, okay, with respect to sine and cosine. Okay, beta function with respect to sine and cosine. To find out this, we let x equals to sine squared theta. Okay, we let x equals to sine squared theta. Okay, then we differentiate it with respect to x, then we get dx equals to 2 sine theta cos theta. Okay, using the chain rule, of course, you know that. Okay, first you have to integrate the whole, that is 2 sine theta, then you have to integrate only the sine theta, that is cos theta, so you get 2 sine theta cos theta d theta. Okay, I hope this much is clear. Okay, now if you find the value of x and theta, so what is the value of x first? What is the value of x? 0 and 1. Okay, means the limit of x is what? 0 and 1. The lower limit is 0 and the upper limit is 1. So here for 0, sine squared theta is 0. So you tell me for what value of theta sine theta will be 0? The value of 0, right? For the value of 0, sine theta is always 0, and for the value of theta, when the value of theta is pi by 2, sine theta is always 1. So here the theta is replaced by the limit 0 to pi by 2. Okay, so now we can write beta m and n is equals to, so the limits of this changed from 0 to 1 to 0 to pi by 2. Okay, so we can write 0 to pi by 2, and see we have let x equals to sine squared theta, so we will just substitute x as sine squared theta. So sine squared theta whole to the power, what you have? You have m minus 1. You have m minus 1. Okay, and now it's 1 minus x, that is 1 minus x means 1 minus sine squared theta to the power n minus 1, and you have d theta. Because okay, I did a little bit mistake. It is not d theta. D theta is replaced by what? No, sorry, dx is replaced by what? Dx is replaced by 2 sine theta cos theta d theta, right? So you write here 2 sine theta cos theta d theta. Okay, I hope this is clear. 2 sine theta cos theta d theta. Now you just need to do a little bit of simplifications. Okay, fine. So equals to 0 to pi by 2 sine. Okay, now multiply the powers. Okay, 2 into m minus 1 means 2m minus 2, so it's 2m minus 2 theta. So 1 minus sine square theta is what? Cos square theta, right? Cos square theta. Now you multiply the powers with it. So upon multiplication it will be 2n minus 2, right? Cos 2n minus 2 theta d theta. Sorry, 2 sine theta cos theta d theta. Okay, so now you see integration 0 to pi by 2 sine 2m minus 2, and you have here the power 1 and here power 1, right? So it is addable, so you can basically add this the powers with this because the bases are same as sine theta. So it will be sine 2m minus 2 plus 1. So minus 2 plus 1 is minus 1, right? So you can write over here sine 2m minus 1 theta and cos, see 2n minus 2 minus 1 plus 1, so 2n minus 1 theta d theta. Okay, so this is basically the form of beta function, okay, with respect to sine and cosine, the form of beta function in terms of sine and cosine. Okay, so I just write therefore beta mn is equals to 2. So you have 2 over here, so you can take this 2 outside the integral part. So 2 0 to pi by 2 sine 2m minus 1 theta cos 2n minus 1 d theta. So this is the generalized form of beta functions in terms of sine and cosine, and this is the algebraic form of beta function. Okay, so in the next video mm, we will see the problems related to beta function and the properties of beta function, and also the relation between gamma function and beta function. So stay tuned with our channel. Okay, and just remember the difference between two things, that is the beta and gamma. In gamma you have only one variable, that is the n. Okay, the full gamma function is dependent upon only one variable, and in beta function you have two variables, that is m and n. Okay, this is the very basic difference between beta function and gamma function. So in the next successive videos this concept will be more clear. Till then, stay tuned and goodbye.